I was cut off in my attempt to continue the last video. Turns out the camera was yelling at me because the battery is low. Okay, and it cut out. Okay, so anyhow, again, this circuit, we have a switch that we can throw this way so that the source will charge the capacitor. Or we can throw this way, taking the source out of it because there's no way for current to flow if the current isn't complete here, or if the circuit isn't complete, so that the capacitor will discharge through the resistor. And the more charge we have on the capacitor, the more voltage we have across the capacitor, and the more voltage drop we're going to be able to have through the resistor, meaning more current through the resistor. The current, of course, is the rate at which the charge on the capacitor flows through the current, and that decreases the charge on the capacitor. So the current is the rate at which the charge changes. Now, the amount of charge determines the current, which is the rate at which the charge changes. So that the rate at which the charge changes is proportional to how much charge you have. Well, that's the basic premise, or the basic situation that gives rise to an exponential function. I tried to say something about that over here and realized there's no simple way to say it because this one needs to be drawn out. It's a little more complicated. This one can easily be understood, okay, if you understand your pre-calculus and even understand it even better having had a good calculus course, which you certainly should have before being in this course. Okay, so just like compound interest, the more money you have, the more interest you earn, the faster your money grows. For radioactive decay, the more of the radioactive substance you have, the more of it is decaying and the faster the amount is changing. For a population, a reproducing population in an unrestricted, ideal unrestricted growth situation, the more organisms you have reproducing, the more increase you're going to have in population. Every one of these cases gives rise to an exponential function. For the population and the compound interest, your exponential function will be increasing. For radioactive decay and for charge on a capacitor, when the capacitor is connected to a resistor, you have a negative rate of change. Your change is your amount is decreasing, but still in a manner that's proportional to how much charge you have. So you expect to get an exponential decay in the charge. And that's exactly what the differential equation gives you. You get Q of t equals Q sub 0 e to the negative t over RC. This Q sub 0 would be if you charge the capacitor up with the switch down this way, then flip it here so that t starts at that instant, so t equals 0 at that instant. Q naught is the full charge on the capacitor, which of course would equal C times V sub S, for the reasons that we saw in the preceding. Okay, so we want to understand that situation as well as this, but we want to understand how the exponential decay can occur in a situation like this, where the exponential approach to the source voltage can occur in this case. And we want to understand these exponential functions at the pre-calculus and calculus level.